Hi, I am Sikandar Rafiq and you are watching the DevCore Learn Software Development channel. In today's video, we will discuss the database architecture, 1-tier, 2-tier and 3-tier architecture. So, after watching the few videos, data independence and data abstractions, if you are curious about how databases and applications are organized in the real systems, then this video is for you. So let's dive into the topic, database architecture and 1-tier, 2-tier and 3-tier architecture. Okay, learning objectives. By the end of this topic, you should understand what database architecture is, why database architecture is important, 1-tier architecture types, 1-tier, 2-tier and 3-tier architecture, advantages and disadvantages of each architecture, real world examples, which architecture is used in modern software development systems. Okay, introduction to database architecture. Now a new question arises: how user actually communicate with the database? Does the user connect directly to the database, or there is an application sit in between user and the database? Where does the business logic execute? So we will discuss all these questions and get answers of all these questions. First, the definition of what is database architecture. Database architecture describes how users, applications and database communicate with each other. So this is the very simple definition. Database architecture defines how different parts of the database system are organized and connected. So which are the users, applications and the databases. Okay, let's see the real life analogy. For example, if you or any customer go to the restaurant, waiter takes the order from you and handed over order to the kitchen, which prepared the food. Waiter, when food is prepared, waiter bring the food back to the customer. So in this case, in scenario, you have seen the customer never directly communicate with the kitchen. It communicate with the waiter only. So similarly, in the modern user usually don't communicate directly with the databases. So kitchen is here, you can see the backend system or backend type. So in the same way, user don't directly communicate with the database. Okay, types of the database architecture. So there are 3 types of architecture: 1-tier architecture, 2-tier and 3-tier architecture. So we will discuss all these architecture in more details. Okay, there is a 1-tier architecture first. All components exist on the same machine. For example, here, as a user, you have installed the database, PostgreSQL. You have installed the PG admin tool, which is used to view the database, tables and all these constraints. And you have installed the application Java or any other application on the same machine. So all the components now exist on the same machine, so which is using the same application and do be using the same memory and CPU, and you are getting the results directly. So this is the example of 1-tier architecture, in which application and the database exist on the same machine, just like application and the DB. So it exists on the same machine. So this is the local development called. So it is called the 1-tier application, 1-tier architecture. So in this case, it has the very limited scalability. Only one user can access this, and single point of failure, no remote access in this case, right? So this type of application has different advantages and different disadvantages. So it's very simple, easy to install, and fast because everything is local, good for learning and testing. But at the same time, it has different disadvantages. Not scalable, only one user can use it. Not suitable for multiple users. Very poor security because the application is directly communicating with the database. Cannot support enterprise applications. So where it is used for learning the DBMS, local development and personal application development and some testing purposes. Okay, so now let's discuss the two-tier application architecture. In the two-tier architecture, client machine communicate directly with the database server. So this involves the two machines. So on one machine we have installed the client application, just like this. Any application, payroll application or any other application installed on the one machine, and the second application we have installed the database, Postgres or any other database. So client is directly communicating with the database. So this is called the two-tier application, or sometimes it is called the client server application. So in this case, client is getting directly communicating with the database and fetching the results. So data is separated in this case, but client logic is tied, skill required, more client installed. So it has it has some advantages and disadvantages. So we will discuss. Yeah, here for example, yeah, this is the one machine which is the client. So application is installed on this machine. So another machine, you can say server. So DB is installed on this machine. So application is directly using this DB server. So this is the two-tier architecture. Two-tier architecture, right? Okay, faster than web-based systems because you are directly communicating with the systems. Easier to develop, suitable for small organizations. But at the same time, it has different disadvantages as well. So business logic exists inside the client application. So every client must install the application, and whenever update is needed, so every client should need to update the application, and every client must maintain the DB connection as well. For example, if there is as I mentioned, it is very limited scalability. For example, if client 2 is using, so this is client 2, so it has also maintained the DB connection here directly with the, so same as the if client 3 is using, so same DB connection, it is communicating directly with this. So it has very limited scalability, weak security due to direct DB connections, right? So where used, it is used in the small office software, point of sales systems, library management system and school management system, when there is a very limited number of clients have to connect to the database. So at that time you can use the two-tier application. So There is a three-tier architecture as well. In the three-tier architecture, separate the system into three independent layers. So first layer is the presentation layer, where the user interact with the application. So here you can see web browser, Android application, you are interacting with the phone, iPhone app, desktop application. So its responsibility is the displaying the data, taking user input. So no database logic here. So presentation layer is connecting to the application layer, which is sometimes called business layer or backend system or API server as well. So we will define this backend system in multiple languages or tools. We can use the Phoenix, Elixir or Spring Boot, ASP.NET and the Django and the Laravel and the Node.js. So its responsibility are the authentication, authorization and the validation. Business rules are implemented here in the application layer or business layer. SQL queries, communication with the DBMS. So this application layer directly communicate with the database. So presentation layer send the query through the REST API to the application layer. For example, this is the presentation layer. It communicates to the REST APIs. So here is the application layer. Or sometimes it is called the backend system, backend server or system. And it directly communicates with the DBMS. So same is here. Third layer is the database layer. It stores the data, retrieve data, transactions. We are creating the indexes and concurrency control, all is managed here. So we can use any database. For example, Postgres, MySQL, Oracle or any other database we can use. So this is the three-tier architecture. Okay, example of the three-tier architecture. First one is the login example. So I will show you, for example, the presentation layer. Okay, so this is the presentation layer. Okay, in this case, in this layer we have sent the credentials, emails and password to backend system, backend server. So backend server verify it, and the, for example, it directly communicate with the DBMS. It fetch the password according to this email, and then verify the password is specified the correct or wrong, and then send the result back to the presentation layer. So in this way login workflow is worked. So the second example is the e-commerce website, buying the example. For example, the same way it is working. So this is the presentation layer. Here buy now functionality. So user buys something, so then request is sent to the backend system. So the backend system it creates the order, okay, it directly communicates with the DBMS. It saves the order in the DBMS, and the same way it verifies the payments, save the payment transaction in the DBMS as well, and then it return the results back to the presentation layer in the JSON form. Normally right now JSON format is used. So it results the OK results in the JSON format. So it's mean the order is created, payment is verified and saved in the database, and then also verify the stock, check stock. So all these business rules, so this is the business rules. So all these are implemented in the backend system, as I mentioned before. So if all these business rules are satisfied, and then we will save the transactions in the database, order transaction, payment transaction, and the update the stock in the database, and then send results back to the presentation layer. So in this way, by now some functionality is implemented. In the current modern e-commerce website applications. Okay, this three-tier architecture has a lot of advantages. It's a better security, as you have seen. Backend system is authorized. It will verify the authentication and authorization. Scalability, so it is very scalable. It can use the hundreds of thousands or even millions of customers can use the applications. So the same way, so this backend system can be used by millions of users. Millions. So that is why it's very scalable. We can scale the database and the backend server as well. So there are lots potential of scalability here. Easier maintenance, we can enhance the front end and the back end code as well. So this is maintenance is very easy. Code use, so as I mentioned, this backend server can be used by the large application. It can be used by the for example, this is the backend system server or system. So it can be used by the Windows desktop application. It can be used by the Android phones. It can be used iOS applications. So it can be used by the large number of applications as well. So better performance. So better performance means we can optimize the queries here. We can cache the data. cache data and the optimize queries, SQL queries, or we can validate the requests. So in this way we can improve the performance of the backend system. So there are a lot of potential to improve the performance. Okay, this is the comparison table layers. So one tier has one layer and two tier has two layers, as we have seen, and three tiers has three layers. Database location in the one tier it's a local, and two tier and three tier it's remote. So business logic is implemented on the same machine in the one tier application, and the two tier it is tied up with the client, but in the three tier application architecture, business logic is implemented in the backend server. So scalability, as I mentioned, the three tier is very high and the one tier is very low and two tier is medium. And security, one tier is low and two tier is medium and three tier is very high security. Maintenance is the one tier is difficult and two tier is moderate, but for the three tier architecture it's very easy. We can easily maintain the client and the backend server and database, etc. Suitable for internet, one tier is no and two tier is very limited and three tier is yes. Modern applications are not using the one tier application. It is very rarely using two tier architecture, but modern apps, web apps, using the three tier application mostly. Okay, this is the real world example. One tier is learning Postgres on your laptop or the local development, and the two tier is the desktop accounting software, office inventory software, and the three tier is the application you are using on the daily basis: YouTube, WhatsApp, Facebook, Amazon, Netflix, and all the banking apps. So all these modern web applications are using the three tier architecture. Okay, there is a common misconception. Browser or application directly communicate with the database. No, browser or application directly communicate with the backend API or backend system, and backend system is communicating with the database. So okay, summary diagrams. Okay, one tier application, user, application, database all in one machine. In the two tier, user and desktop application on one machine and the database server is on the another machine. So this is the two tier architecture, and in the three tier architecture, front end is on another machine and backend system is on another system or machine, and database may be on the another system or machine. So this is the three tier application architecture. Key takeaways: database architecture defines how user, application and database communicate. One tier is best for learning and local development. Two tier architecture is suitable for small client server applications. Three tier architecture is standard for modern web and mobile applications because it offers better security, scalability and maintainability. So thank you so much for watching the video. So in the next video we will discuss the transactions and asset transactions. Thank you for watching.